Hi, guys. I just wanted to help you and go through what we've kind of been talking about this week with polynomials, the basics and understanding how to add and subtract. Yesterday, we posted a video about adding and subtracting when you had algebra tiles. Now, it's a great way for you to visually see it, but I want to go through and make sure you guys understand how you were doing it and how to do it without having algebra tiles. But the first thing I want to do is I just want to go over a few things about the basics of polynomials first. So with that being said, you have to remember a polynomial is a monomial or the sum of monomials. So you have to think back to when you learned in English this year with your prefixes, and mono means one. So a monomial, you guys, is just a term, okay? And this can be anything as 3x or 4x to the fifth power. That is a monomial. When we start combining multiple terms, that's when it turns into a binomial or a trinomial. A binomial, we know the prefix is bi, which means 2. So that would be like 2x plus 5. That would be your binomial. Now we know tri means 3. So that would be like 3x to the fifth plus 7x minus 15. That would be your trinomial because there are 3 terms in it. Now, all of these can just be referred to as a polynomial. And especially when we get to bigger ones, we just call them polynomials. Now, another thing that I know some people were kind of struggling with was the degree of the polynomial. So the biggest thing, remember, the degree is the highest exponent. It's that largest exponent. So here, that would be a 5. If we look down here at the other example, 3x to the fifth plus 7x minus 15. That 5 is the degree because it's the largest exponent. Also, remember, you have linear, quadratic, cubic. These are different types of polynomials. This is when we really get specific. Linear, you guys, we've been working with this all year. It's when we have a degree of 1. These are your basic 3x minus 1 or your slope-intercept forms. And I know we talked about that when we did our parent graphs, and we talked about that with the exponent of 1. Quadratic, your degree is 2. So that largest exponent you're going to see is a 2. And that right there, that 3x squared. Cubic would mean exponent of 3. 3x cubed minus 5x plus 2. Quartic is 4, quintic is 5. Again, those are the largest exponents. Now, one thing I want you guys all to notice right here in this example section is it goes largest exponent to smallest, 2, 1, none. Because we know when there's nothing there, that's the same thing as saying x to the 0 power. So remember that. That is why it's going in descending order. And we're going to talk about that in the next page. This is when we talk about normal form of polynomials. So normal form, it's when our exponent is going from the largest to the smallest. So here in this first one, we've got 3x cubed plus 4x minus 9x to the fifth. This would not be normal form because our largest exponent is right here in the middle. So that would go over here. Now, 6x plus 2, this is in normal form because we have that exponent of 1 here, and then we don't have anything here. Okay, now we have 5x minus 7x to the fourth plus 3x squared. Again, we look, these exponents are not going in descending order. And then the last one, we have 2, 3, 2, none. And a big thing I want you to remember, you guys, it's okay. They don't have to go in chronological order. It doesn't have to be 3, 2, 1, 0. Because basically, as long as we're just counting down. Okay. So a big thing, you guys, is when we're working with these, it's important that we put it in normal form, or sometimes you'll hear it referred to as standard form. Okay? And again, when we talk about normal or standard form, we're going largest exponent to smallest. Now, it's important that you also can name the leading coefficient. And that leading coefficient, when you are in normal form, it's the number that is always in front of the variable that has your degree on it. So it's always going to be that first number in your expression. Then we're going to have to name our degree, which again, that is our largest exponent, and the number of terms. And that's how many there are in there. So if we look at the examples below, we have 7x cubed minus 3x squared plus 1/2 x plus 5. Now, if we look, the first thing we have to decide is if it's in normal form. And if I look here, I notice that I'm in normal form because I have 3, 2, 1, none. So we already know that this is in normal form or standard form. I just want you guys to understand you're going to hear it both ways. So the next thing we need to do is we need to name our leading coefficient, our degree, and the number of terms. So if we look, our leading coefficient, if we're in normal form, our leading coefficient would be right here, and that would be a 7. Now, like we talked about, our degree is always going to be that largest exponent. And if you have it in standard form, it's going to be that first exponent. So we know our degree would be 3. Now, to figure out how many terms, 1, 2, 3, 4. And that's how we would do that. Biggest thing you need to remember when you are writing in standard form, and if you have to rearrange, remember the sign that's in front of the number stays with that term. So if we look at number 2, I've got 5 minus 3x squared plus 1/2 minus 7x cubed. So if we first look at this, we notice it's not in normal form. So the first thing we have to do is put it in normal form. So to put it in normal form, we got to look and we've got to find the term with the largest exponent. And we see that that's here. You guys can also, if need be, combine like terms. So we would have our negative 7x cubed. Now you look for the next largest exponent and we see that that's that x cubed squared. So now we have 3x squared. Then we would go to the next largest, which would be 1/2 x. And then last, we would have plus 5. And remember, when there's not a sign in front of the number, that's a positive. So now, if we look at this, we can label our leading coefficient, our degree, and our term. So if we look again, our leading coefficient, what is the number that's in front? And if I look here, it's a negative 7. My exponent, so what is the largest exponent we see? It is a 3. And then again, how many terms? 1, 2, 3, 4. All right, so I'm hoping that makes a little bit more sense. Again, we will go over this more on Monday in our live instruction. Now, like I said earlier in the beginning, when we talked about adding polynomials, we showed you that video yesterday of using algebra tiles. And it's a great way to see all you were doing is combining like terms. So I just want to go over right now how we can add polynomials without algebra tiles. So the biggest thing you need to remember, when you are adding polynomials, you're just going to combine the like terms. And you need to remember, like terms, they're the same variable. But if our variables have exponents, they have to be the same exponent. So right here, I give you an x squared and an x cubed. Since those exponents aren't the same, we can't combine them. But if I had a 3x to the 4th minus a 5x to the 4th, we can combine those. And we would just do our 3 minus 5, which is negative 2x to the 4th. And the big thing you have to remember, don't change the exponent. Because again, when we are adding and subtracting like terms, we just are working with the coefficients. The variable and the exponent stays the same. And always, last but not least, you need to make sure your answer is in normal form. So, like I said, never change we're only going to change the coefficients, never change the exponents. All right, so if we look at this example here, so I'm going to start with a tough one, but I know you guys can handle it. We've got 3 polynomials here. The reason we know we have 3 is because there's 3 sets of parentheses. Now, there's lots of different ways to do this, but the way I like to do it is when I start, I like to start just by putting it in normal form right away. And what I do is I underline or I circle or I do different things so I know when I've used those correct terms. So I know for normal form, I have to have that largest exponent. So what I do first is I look through and I find that largest exponent. And when I look, I see I've got this x to the 5th power. So I have 5x to the 5th. I look, I have nothing else to combine with it. So I know I can just bring that down. Next, I look for the next largest exponent. I've got 2, 1, none, 2, none, 1, 2, none. Oh, I've got a 3, and I know that's the next largest. So then I know that this, my negative x cubed, would come next. So now I have to look for my next set of terms. And if I look, I've got an x, 2x squared, a 3x squared, and a 4x squared. So 2 plus 3 is 5, plus 4 is 9. And again, we don't change the exponent. So now I'm going to have plus 9x squared. Now I look, and I have my negative x, my negative 4x, and those are the only terms with x. So negative 1 plus negative 4 is negative 5x. And last but not least, I have 7, and negative 8. So I know 7 plus 7 is 14, minus 8 is 6. So now if I look at this problem, I've got to make sure my answer is in normal form. And again, I go 5, 3, 2, 1, none. So I know I'm in proper form. We also know that our degree would be 5. Our leading coefficient would be 5. And here, again, 1, 2, 3, 4, 5. 5 terms. All right, so I'm hoping that it's helping you with adding, okay? We'll do one more example here, okay? Now, another way to do it, just so you know, is you don't have to put it in order right away. So what I mean by that is if I look at this problem, I've got 13n squared. I also have a 13n squared here. So when I combine those, I get 26n squared. Now, my next set of terms would be my 11n and my 3n. And when I combine those, again, they're all plus signs, I get 14n. And last but not least, I've got my 2n to the 4th and my 6n to the 4th. So when I combine those, I get 8n to the 4th. Now, the biggest thing you have to look at, this is not normal form. So we do have to switch it to normal form. And again, largest exponent to smallest. So that means we would have 8n to the 4th plus 26n squared plus 14n. And again, our degree would be 4. We would have a leading coefficient of 8, and we would have 3 terms. All right. So adding is really easy. All you're doing is just combining like terms. Now, for subtraction, I know we're trying not to, but think of keep, change. You always want to change your problem to an addition problem. So if you see a subtraction sign, you're going to change it to an addition, and then you have to remember to change the sign of every term in the parenthesis after that. And then it just turns into a nice, easy addition problem. All right, so if we look at this first example, we see we have a minus sign here. So like I said, the first thing we want to do is change that to a plus sign. Now, since we changed that, we've got to change every term after. Now, by doing this, we're just going to follow the same rules as before. All right, so like I said, I like to look for my largest exponents first because I like to cut down on the amount of work I have. So I look and my largest exponent is that negative 2 to the 4th. So the first thing I would write would be negative 2x 4th, because remember that negative stays with it. Now I look, my next largest exponent here is this 2x cubed. And like I said, we changed it to a plus sign. So now I have plus 2x cubed. And next, I look for my next exponents. Here, I've got an x squared. I don't have any other x squared, so I'm going to bring it down as plus 5x squared. And then I've got a negative x and a negative 3x. Remember, we changed that. So negative 1 plus negative 3 would be negative 4x. And then I've got 8 plus 4, which would give me 12. Now I look. I'm already in normal form. 4, 3, 2, 1, none. So I know my leading coefficient would be negative 2. My degree is 4. And then I have 1, 2, 3, 4, 5 terms. And last, let's look at one more example. Again, we've got a minus sign. So like we said, we're going to change that to a plus, which means we've got to change every other sign. So now we look. My largest exponent would be that negative 2x to the 4th. Then I look. I just have that x squared, so I'm going to go plus 3x squared. But now I look, and I've got a negative 5x and a positive x. So negative 5 plus 1 is negative 4x. And then last, I've got 3 plus 4, which is 7. So my leading coefficient here would be negative 2. My degree is 4, and I also have 4 terms. All right. So I'm hoping that this helped you guys with our lesson for today and understanding how to work with adding and subtracting. If you don't get it, it's okay. Make sure you try the homework, and we'll go through this more on live instruction on Monday. Have a great week.